Okay, so hello everyone. Now, as we were discussing about this subject, basic signal and system. So till now, what we have discussed? We have discussed Fourier series and Fourier transform. And in the last lecture, we have discussed about the different properties of Fourier transform and how the properties of Fourier transform help us in solving a numerical problem easily. And today we will see, first of all, we will see some Fourier transform common functions, like which the functions which are repeatedly we face. We will see how to calculate Fourier transform of this, because see mostly there are few functions repeatedly we get those function or modified form of those function. So, it help us if we know the Fourier transform of, for example, suppose if we know the Fourier transform of exponential function or e to the power minus at, or if we know Fourier transform of some function, rectangular function or triangular function, then if we get the combination of any of these, or we get addition or subtraction of any of the signal, so we can easily modify the result and get the desired output. Okay. So today let us see what are some common function and how we can get the Fourier transform of that function. See, so the very important parameter, or one of the it is not the property basically, but there is basically two tool, like how we can find that is, one is area under time domain and area under frequency domain. What does it mean? That means, suppose if you are given a function, if you are given any function x t, okay, and we are required to find out the area of this, or if you are given x omega, or we are required to find the area. So, means if we have a function in time domain or frequency domain, or if we have function in time domain and we are required to find the area of that function, okay, then how we can easily find? See, the basic formula, as we know, what is the formula for finding area of any function? As we know, minus infinity to infinity x t dt. So, this is the basic how we find the area of the given function. But now suppose if you are required to find, so basically this is under integration. So, if there is some complex function, then it is very difficult to integrate. So, there is one property, based on Fourier transform, which help us in getting this value of this area in the frequency domain. So, the property is basically, see, area under time domain is equal to x omega at omega is equal to 0. Okay. See, that means if we have the Fourier transform of any function x t, if we have Fourier transform of any function x t and we are required to find the area, then what we have to do? We just have to find the Fourier transform of that function. We just required to do the Fourier transform of that function, and the value of that Fourier transform at omega is equal to 0 is basically the area of the time domain. We can also derive, see how we can derive, see what does Fourier transform mean? See, when we say Fourier transform, means x omega is equal to minus infinity to infinity x t e to the power minus j omega t dt. So, this is basically Fourier transform, how we find the Fourier transform. Now, suppose in this function if we keep, so in this function if we keep omega is equal to 0, in this function if we keep omega is equal to 0, what we will get? We will get x omega is equal to 0 is equal to minus infinity to infinity x t, and this function will become 1. So, this is basically your area, So, at what point we will get that area value? At omega is equal to 0. So, just remember that this is a very one of the useful tool where you can, when you are required to find the area under time domain. So, just we have to find the Fourier transform, and the value of Fourier transform at omega is equal to 0 will give us what? The value of that area in time domain. Okay. Similarly, we have area under frequency domain, means if we have Fourier transform, of any function and we are required to find the area of that Fourier transform or function we have got after doing Fourier transform, then what we will do? So, this says area under frequency domain, that means area of x omega is equal to 2 pi x t at t is equal to 0. So, what we say 2 pi x t t is equal to 0. So, this also we can prove. See how? See what is area, if you area of, what will be area of x omega? It will be basically integration minus infinity to infinity x omega d omega. So, we are required to find this. So, see, and we know x t is what, 1 upon 2 pi minus infinity to infinity x omega e to power j omega t dt d omega. So, this is basically what is this? If you remember, this is what basically inverse Fourier transform. Inverse Fourier transform means when we have the Fourier transform and we are required to find the function x t function, then we can write like this. Okay. Now, so what so in from this function what we are required to find? We are required only this much of, this is only the concern. So, we will shift 2x here. So, we will get 2 pi x t is equal to integration minus infinity to infinity x omega e to power j omega t dt. Okay. So, now from this what we have to, we are requiring only x omega by d omega. So, what we will do, x omega, sorry here omega. So, what we will do, here we will keep t is equal to 0. So, when we keep t is equal to 0, then here we will get 2 pi x t at t is equal to 0, and this function will reduce in the form what, minus infinity to infinity x omega e to power 0 d omega, that is infinity minus infinity to infinity x omega d omega. So, this is what we are requiring. So, what we got, area under frequency domain is 2 pi times the value of function in time domain at t is equal to 0. Area under frequency domain is 2 pi times the value of function in time domain at t is equal to 0. So, remember this. So, this is basically two properties. Now, we will see the most common or some common function through which we can get the what, Fourier transform, some Fourier transform of some common function. So, the most the very basic is this. See, very often you will find, you will be required to find e to power minus a t u t dt. Very commonly you will see the finding the Fourier transform of this function, that is exponential function. So, how we will get this? See, what is Fourier transform f t? If we are required to find the Fourier transform, we will do e to power minus a t, and here we get e to power minus j omega t dt, then here sorry u t dt, or here there one condition, a is greater than 0. So, when we will solve this, we will see what is the importance of this a greater than or equal to 0. Again minus infinity to infinity e to power minus a plus j omega t u t dt. Then here, as you know ut, you know ut function, unit step is basically a function which is can be written as 0 to infinite, and it is 0 from 0 to minus infinity. So, this limit will change and it will become 0 to infinity e to power minus a plus j omega t dt. So, what this is basically, so basically this point is replaced by this, I change the limit. So, what we got now, if you find the integration of this, what we will get? We will get so what is the integration of e to power minus t? So, basically it is what, e to power minus t upon minus 1. So, here you will get 0 to infinity e to power minus a plus j omega t minus 0. So, when you will solve, you will get 1 upon a plus j omega. You will get 1 upon a plus j omega. So, remember the result, the integration of e to the power minus a t u t dt gives us 1 plus a plus j omega. See what is the importance of getting this a greater than 0. See, when you will keep the limit, you will get e to the power minus a t and e to the power j omega t. Okay. So, here if suppose value of a is negative, then what, this whole function will become what, e to the power positive some function t. So, and you will keep t is equal to infinite, then the whole function will become infinite. When a is positive, as it is given in the question, it is given condition that a is positive, in that case what will happen, when a is positive, so minus a t will be negative, and then e to the power minus a t can be written as 1 upon e a t, and you will get the what, function some finite value. Otherwise, if a is negative, then there are chances of getting infinite value. Okay. So, always remember the Fourier transform of e to the power minus a t u t dt give e to the power minus a t u t gives us what, at for the condition a greater than 0 as 1 upon a plus j omega. Okay. Now see next one. Now we will see next question. What, this is basically, suppose now also if you know e to the now as we have seen in the property, if x t, if Fourier transform is x omega, then what will be the Fourier transform of x minus t? It will be what, x minus omega. So, what we have seen? We have seen e to the power minus a t u t Fourier transform is what, 1 upon a plus j omega. So, if someone asks you what is Fourier transform of e to the power minus a t u to the power minus t, means e to the power minus a t u minus t. So, what will become? What we have to do? We have to replace here what, t is to be replaced by minus t. So, it will become, here minus t will become plus t, and here t become minus t, and here we will get 1 upon a, from this property we will get a minus j omega. So, remember this property as well, if that Fourier transform of e to the power minus a t u t is 1 upon a plus j omega, then the Fourier transform of e to the power a t u minus t gives us what, a 1 upon a minus j omega. Okay. What we have, what property we have used? We have this time reversal property. What does time reversal property says? The time reversal property says if Fourier transform of x t is x omega, then the Fourier transform of x minus t will be what, x minus omega. So, using the property we have got this Fourier transform of 1 upon a minus j omega. Okay. Now, next function, let us take the next function. The next function is what, x t e to the power minus a modulus t dt. Suppose this is the function e to the power minus a modulus t dt. Okay. If we are required to solve this, here also we have condition a greater than 0. Okay. So, see, as here time is under modulus, so we know where is modulus, what does, so we can expand this and write like this, e to the power minus a t for t greater than 0 and e to the power minus or plus a t for t less than 0. So, how we can write this both function in another form? We can write, see, do we have any function, or do we have any function which can have positive value for t greater than 0 and negative value for, or 0 value for t less than 0, or so here we can write it like this, e to the power minus a t u t, e to the power what, we can write e to the power minus a t u t, and similarly plus e to the power plus a t u minus t. Okay. So, we can expand it like this, e to the power minus a t u t and e to the power a t u t. How we written this? Because see, if t is greater than 0, then e to the power minus a t, and if t less than 0, then here t become minus t and it will become plus at. So, t less than 0 means what? Ut becomes what? U minus t. If you apply time reversal in this, what you will get? T less than 0 and ut become minus u minus t. So, now if now find the Fourier transform of this, just now we have found 1 upon a plus j omega, and for this also we have found 1 upon a minus j omega. So, combining both, what we will get? We will get 2a square plus omega square. So, this is basically Fourier transform of what? Fourier transform of x t e to power minus a t dt for a greater than 0. See, this is very important, you have to remember. If you get, see, as we know, one of the very important property we have studied was duality. So, if anywhere you find x t in this form, so just we will see one next problem based on this. If you find some function time domain in this form, in a square plus b square form, then using the property of duality we can write the reverse answer, or you can write the Fourier transform. So, now just see what is the example. So, the question is see, basically the question is, if x t is equal to 1 upon a plus j t, question is if the function is x t is equal to 1 upon a plus j t and we are required to find the Fourier transform of this function. So, see how we can find, see if you remember the property of duality, if you remember the property of duality, what does it say? It says if x t x omega, if we have some x t for which Fourier transform is x omega, and we have some function which is in the form of, or which is have similar structure like x omega, and we are required, if we are required to find the Fourier transform of that x omega, then what we have to do? We have to replace t by omega by t, and finally we will write 2 pi x minus omega. So, this was what? The property of duality. Okay. So, here now see, if you remember, does any of the Fourier transform we have just studied, if any of the Fourier transform is similar to this form? So, yes, you will say yes sir, 1 upon a plus j omega, the Fourier transform we got for what? E to power minus a t u t for a greater than 0. So, this we got from what? E to power minus a t u t. So, this given function is a form of what? 1 upon a plus j omega. So, now if you are required to use the property of duality, so how we will do? See, so how we will do? So, first what you have to do? You have to replace omega by t, So, here replace replace t by omega. So, what you have to do? You have to replace omega by t. So, here you will get 1 upon omega by t. So, what you have to do? Here you will get 1 upon a j omega. Okay. So, what you have to do? We have to replace t by omega. So, here you will get 1 upon a plus j t. Okay. No, sorry, change it here. It will be like, okay. So, here now what we have to do? We have to replace 2 pi x minus omega. So, what we will do? We will 2 pi, and what is x omega for this? So, x omega for this will be what? This. So, e to power minus a t dt, e to power minus a t. Okay, do it again. Not like this. See, what is given? Given x t is 1 upon a plus j t, and we are required to find the Fourier transform of this function. So, using the property of duality, what we will do? First we will replace t by omega. So, you will get what? 1 upon a plus j omega. Okay. What we will get? We will get 1 upon a plus j omega. Now, what you have to do, and we know that this form is for Fourier transform of what function? E to power minus a t u t. So, what we will do? We will write here e to power minus, what is the function? We will write e to power 2 pi x minus omega, x minus omega. So, this is basically x t. So, how we will write x omega? So, x t is this. So, x omega will be what? So, x t is basically e to power minus a t u t. So, x omega will be what? E to power minus a omega u omega. So, here replace. So, 2 pi x to power minus omega, it will become 2 to power x minus omega will become 2 pi e to power minus. So, here minus minus become plus and u minus omega. So, this will be the basically the result. This will be basically the result 2 pi e to power a omega u minus omega. Let us see one more problem based on duality. See, just now we have seen what one more thing. If something is given like this, x t is equal to 2a square plus omega square, and we know that e to power minus a t a greater than 0, Fourier transform for this function is 2a square plus omega square. Okay. The Fourier transform of this function, we know that this is 2a by omega square, but someone asks us that find the Fourier transform of this function 2a upon a plus j omega. If someone asks us to find the property the Fourier transform of this function, so what we will do? By using the property of duality, what we will do? We will replace it by 2a square plus t square. We have replaced this omega by what? Replace omega by t, and then finally we will replace 2 pi x minus omega. So, basically x t. So, what is x t? So, this is basically x t. We have to replace t by minus omega. So, here we will write 2 pi e to power minus a minus tau. So, this will be the here we will write omega 2 to the power e minus omega. So, minus will be here. So, as you know, there is no meaning of minus under modulus. So, it will be basically 2 pi e to power minus a omega. So, this will be the basically function what for, and also condition a must be greater than 0. So, this is basically the important tool of duality. See, one more place where duality is helpful. See, if someone asks you find, suppose x t is given, see x t is given, and if someone asks you find the Fourier transform twice, for example x t to x omega, and again someone asks you find the Fourier transform of this, means someone asks you find the double Fourier transform of any function. So, at that place also we can use the property of what? Duality. How? See, what I said, suppose if given function is x t and someone asks you find Fourier transform of this function, again it asks you find the Fourier transform, means Fourier transform first time, then again Fourier transform for second time. So, if someone asks you find the Fourier transform for the 2 time of any given function, then how we will do? See, how we will do? Suppose for example, if there is e to power minus a t u t a greater than 0. So, here we will do Fourier transform, we will get what we will get? We will get 1 upon a plus j omega. Again someone asks you find the Fourier transform of this. So, just now we have solved the function, and what we have got? We have got what? E to power minus a omega u minus omega. So, here also we can use the property of duality to solve problem like this, where we are required to find the Fourier transform twice. Okay. So, remember the property of duality, it is very useful tool, you can use it multiple way. Then again the very important, if x t is del t, then Fourier transform for this is basically what 1. How? Integration minus infinity to infinity del t e to power minus j omega t dt. As we know, this function, this is basically, if you remember the property, x t into del t minus t naught is equal to what? X t naught. This is what property of what? This impulse function, that x t multiplied by del t minus tau is basically x tau. So, here what we will do, del tau will keep e to power minus, and here we have 0. See, because it is there is no delay, means here it is del t minus t naught and t naught is what 0. So, you will get e to power minus j omega into 0 dt, basically integration of, so basically integration will be 0. So, what we will get here, we will get f 0, sorry, here we will have to find just what, no, this is wrong. So, what we have to do? So, what we have to do? We have to find del at what t is equal to 0. So, what is function of del? What is function of del? What value of del at t is equal to 0? If you remember this, this is basically del t. It has only value at t is equal to 0. So, del t at t is equal to 0 is equal to 1. So, here we will get 1. So, integration of, so basically the Fourier transform of del t is 1. Next, again see, now suppose if integration Fourier transform of del t is 1. Now, if someone asks if for the Fourier transform of a naught, which is basically a DC value or fixed value, then for this what we will get? We will get Fourier transform as what? 2 pi a naught del omega. How we will get this? We just use the property of what? Duality here. We will just use property of duality and we will get this. How? See, if 1 is Fourier transform of what? Del t, then you have to find for a naught. So, for a naught what we will do? A naught del t, and now 2 pi x minus omega. So, here we will get 2 pi del 2 pi into a naught, 2 pi del minus omega into a naught. So, we will get 2 pi a naught del omega, because del minus omega is equal to what? Del omega. There is no change if you change the time reversal. So, del minus omega is basically del omega. Okay. So, these are some common examples or common Fourier transform of some function. Now, in next lecture we will see how to solve Fourier transformer problems, and we will see if there is some question how we can make use of the properties and the Fourier transform of common function to get the answer of any question based on Fourier transform. Okay. Thank you.